In this lesson, we are going to discuss precise definition of a limit. We say the limit as s approaches a is the number L. For every epsilon greater than 0, there exists a delta greater than 0. If the absolute value of s minus a, which is the distance between s and a, is less than epsilon, then the absolute value of f of s minus L, which is the distance between the function minus the limit, is lesser than epsilon. Now, what do we mean by this? I'm going to use a graphical representation to explain this. But before I do this, you need to know that A is associated with delta, while L is associated with epsilon. L is the limit, A is the value we are trying to approach, then f of s is the function. Suppose we have a continuous function f of s. We are going to have a point on the x-axis. We're also going to have a point on the y-axis. On the x-axis, the point is going to be a. So this is the value we are trying to approach. On the y-axis, the point is going to be L. So this is the limit. Now we are going to pick 2 points around a. So to the left of a, we are going to pick a point. To the right of a, we are also going to pick a point. To the left of a, we are going to pick a minus delta. Then to the right of a, we are going to pick a plus delta. A minus delta is lesser than a, while a plus delta is greater than a. We're also going to pick 2 points to the left of L and to the right of L. So to the left of L, we're going to pick L minus epsilon, while to the right of L, we are going to pick L plus epsilon. L minus epsilon is lesser than L, while L plus epsilon is greater than L. Now, suppose we have a range on this point, meaning we are going to connect the intervals on the x-axis to the intervals on the y-axis. So let's connect the intervals. So connecting the intervals, we are going to have something like this. Now, for the limit to exist, they need to be between this shaded region. For a limit to exist, they need to be between this shaded region. If the limit is outside this shaded region, meaning the limit does not exist. But if the limit is inside this shaded region, meaning the limit is going to exist. In a nutshell, what are we trying to say? What we are trying to say is, if we guess a delta and we evaluate this delta, if we have an epsilon, meaning this limit is indeed going to exist. But if we guess a delta, then we evaluate the delta, but we don't have epsilon, meaning this limit do not exist. So this is what we know as precise definition of a limit. For a limit to exist, whenever we assume delta, we need to get an epsilon for the limit to exist. If we assume theta, or if we assume delta, then we have a different value other than epsilon, meaning the limit do not exist. So this is what we know as precise definition of a limit.